Hello, everyone. Sorry for the late start there. Welcome to another live episode of Visual Studio Toolbox. I'm your host, Leslie Richardson, and today I'm joined by Steve Smith, who is a Microsoft MVP, mentor, trainer about how to have better software at the end of the day. And today we're going to be talking about how to leverage clean architecture in ASP.NET Core apps. So welcome, Steve.
Thanks. Glad to be here.
Sweet. Yeah, thanks for being here. So would you like to share a little bit more about yourself and what you do on an average day basis?
Yeah, I am one of the founders of Nimble Pros, which is a consulting company. We help teams write better software faster. I do a lot of work with architecture. I'm very, very fond of domain-driven design, and fortunately, domain-driven design ties really nicely in with clean architecture, which also ties in really nicely with building things like microservices and stuff, which of course are very popular today. So that's part of what has drawn me into these topics. A few years ago, I put together a clean architecture solution template on GitHub. And so I thought maybe today we could spend a few minutes talking about clean architecture in general and like what is it, why would you want to use it versus other ways of structuring your stuff, and then look at this specific template and how you could use that for your projects.
Absolutely. Yeah. So do we just want to dive into why is clean architecture so important and why should people use it?
Yeah, that sounds good. Let me just throw my slides up.
Yep.
There we go. All right. So let me get through a couple quick things where people can find me or find additional resources if they need to. Where's my slide controls? There we go. So there's a Pluralsight course on domain-driven design that talks a lot about the principles that kind of relate to this. If folks have Pluralsight access, they can check that out. There is a free Microsoft ebook that I wrote that's available with the eShop on Web sample, which is like a full-featured application that uses clean architecture. You've got my information here if you want to talk to me. And beyond that, got a newsletter and some other stuff. All right. So I want to go through this a little quickly as far as the slides because I don't want to bore people and we're already a little bit behind time. But there are a couple of principles that really guide this architecture. So the first one is the idea of separation of concerns, where you don't want to have low-level concerns like data access or how you talk to the cloud or things like that, coupled with your high-level concerns of like, what is the business abstraction we're trying to do? I'm trying to process an order or create a new insurance claim. That doesn't need to be concerned with which type of data store I'm using or something like that. So separation of concerns is a big one. The big three that you want to keep separate are generally data access, business logic, and then your UI. And so we'll see how that's kind of like one of the larger breakdowns that you get in clean architecture. Now, that's not unique to clean architecture. There's other architectures out there that are very popular, which we'll talk about in just a minute. They use the same breakdown, but they don't have the same benefits as clean architecture, and we'll see why in just a minute. Another principle is single responsibility. You don't want your classes to be doing too many things. Kind of relates to separation of concerns. So you want to make sure they only have one reason to change, usually along the spectrum of different classes of different kinds of things that class might be doing, like validation or persistence or business rules or things of that nature. All right. You want to try not to have too much repetition in your code. Getting rid of repetition sometimes introduces coupling. So you can't just get rid of all repetition. But if you see the same kind of cross-cutting concern and you have to write code for it again and again and again, there's usually a better way to structure that with some patterns. Things like the decorator design pattern come into play really a lot of the time for that type of thing. So we'll skip some of that and some of that, and we'll talk about dependency inversion. So single responsibility and dependency inversion are kind of the two ends of the solid principles, where the D is the D in solid is dependency inversion. And with dependency inversion, the idea is that you don't depend on low-level details. And so if we look at the definition for this, it's that both your high-level classes and your implementation detail-level classes should depend on abstractions, which in C# generally is going to be interfaces. And so this ties into clean architecture quite a bit, as we'll see, because it definitely leverages the dependency inversion principle quite a bit. Another related principle is the explicit dependencies principle, which says that your classes, your services especially, should request all of their dependencies in through their constructor. That means they should be explicit. They should like list them and say, here are the things I need if you want me to do my job correctly. So what this does is it eliminates hidden dependencies so that when you're creating a class, you don't start using it and then find out at runtime that, oh, it needed this connection to this database or this configuration value or something like that. If it needs those things, it should ask for them up front. I liken this to if you're cooking and you've got a recipe and you read the ingredients for the recipe to see if you've got everything you need, and you check the refrigerator or whatever, and then you're like, great, I'm going to make this. And you start going through the recipe, and then halfway through the recipe, it's like, oh, and you also need this, a pound of something that it didn't tell you about. You're like, I don't have that. Like, why are you telling me that now?
It's like I'm already halfway through mixing everything.
You're already halfway through. Like, you already wasted all the ingredients you got. Like that.
Yep.
That's frustrating. Don't frustrate people that are trying to use your classes. Tell them everything that it needs at the top. All right. So because of the dependency inversion principle, and because we don't want to depend on the implementation details, we want to depend on the abstractions and the interfaces, we want to put those abstractions somewhere that they can be accessed by the low-level details, by the high-level business services that are going to use them, and also by the user interface entry point that spins up the application. That's where we're going to do dependency injection, and we're going to call configure services in our .NET Core app. So they need to be accessed by all these things. So that kind of tells us in our solution structure, where do we have to put the interfaces so that all these things can get to them? And we'll see that in just a second. All right, so then why do we need these interfaces? What's the reasoning behind it? The main reason is so that we can break apart the two pathways that our code tends to run through. The first one is at compile time. Right, in a strongly typed language at compile time, the compiler is going to verify that class A can reference class B, can reference class C when your code is doing something like in class A, it news up an instance of class B and calls a method, and in that method, it news up an instance of class C. Right, so when you run this code, the control flow is what you see on the right, and it is a direct mirror of the reference structure. That's what all your code always looks like if you don't use any interfaces or abstractions. As soon as you start introducing interfaces, though, now we can make it so that at compile time, it looks very different from at runtime. And at compile time, we depend only on an interface. And at runtime, we can decide which implementation we want to use. And that has a lot of benefits when it comes to writing modular software, writing testable software, being able to upgrade software in a safe manner because you can just replace a module instead of having to change it. All these things have a lot of benefits for the quality and maintainability of our code. So these are the kind of the setting the stage for why you want clean architecture. Then for architecture in general, right, the goal is to make the right thing easy and the wrong thing hard. So the reason why you're bothering with having some kind of structure that you're going to use for your application is to make it so like by default, the easiest thing you could do in that structure is going to be the right thing. And not that you've got this, thing where you have to remember to do things a certain way or else everything falls apart. You want it to just be like obvious that you do the right thing. Force your developers into the so-called pit of success. Okay. So,
I love that piece of advice. That's great words to live by.
Yeah, I didn't make it up. I heard it from various places, but I think I agree. They're great things you want to strive for.
Because I just think of like, especially when you are learning up on an existing code base or have to expand upon an existing one, and these practices aren't being followed, it's so difficult to figure out how to squeeze in your contribution or even understand what you're doing sometimes.
Exactly. All right. So things we want to do is avoid directly depending on the infrastructure from UI. Now, why? Well, because we're following the dependency inversion principle. We don't want to have some controller class that's directly opening a file or talking to a service when we want to have that go through an abstraction through an interface. And so we shouldn't have it call into the infrastructure class things, infrastructure being stuff that talks to things outside of your application, right? Whatever that might be. But if it's outside of your application's process, it's an infrastructure concern and it should be pushed over there. We also want to make sure that the business domain classes also don't directly depend on those. And so that's going to inform how we design our solution. We want to take care that certain patterns and cross-cutting concerns can be dealt with in a simple way that affects the whole app at once without us having to copy paste the code over and over again. So that's another goal. And so with those goals in mind, let's talk about a pattern that has been around for many years, which is sort of this classic N-tier architecture. And this is a pattern that I taught and was one of my first conference speaker engagements. Like my session was on this in 2001. And one of the slides I had was this one, which is from MSDN, the old Microsoft documentation site for developers. And this is a great example of what, N-tier architecture looks like, where you have your presentation or user interface layer, and it talks to, maybe a business layer of some sort, and then a data access layer, and then ultimately it talks to the data source. And so, to simplify that, it looks something like this. And the arrows represent dependencies. So your data access layer is written for a specific data technology, right? So you've got a data access layer that's talking to SQL Server, which is different from one that might talk to Oracle or what have you. And so it's got a dependency on the database, including its structure and other things, right? And then the business layer depends on the data access layer, which means it too depends on the database, because these dependencies, they're all transitive. And that, of course, means your UI layer depends on the database. So at the end of the day, with apps that are built this way, of which there are many, and I've built a few in my career, everything ends up depending on the database. Now, this can be a problem if you're trying to build things using unit tests and continuous integration servers that can just spin up and run all your unit tests and not have a database sitting there ready to go. There's solutions where you can use a test database or sometimes an in-memory database or other things, but it's a lot easier if you don't need that stuff and you can just unit test things, in my experience. Okay. So
it's a large burden on the database.
What's that?
It's quite the large burden on the database.
Yeah, exactly. And for a lot of companies that have followed this for a while, and they have more than one app, right? Some of them have dozens or hundreds of apps. A lot of times they only have one database, and everything depends on that same database. It's like
so really, the database goes down.
Really painful.
Yikes! Yeah.
Yeah. All right, so we can flip this. We can apply that dependency inversion principle and create a domain-centric design, which goes by many names, but clean architecture is probably the most recent and common today. And the idea is that you've got a domain model. So if you're following domain-driven design, this would be your domain model, and it has a model of the problem space. So it has entities and interfaces and services, other things that make up your understanding of the problem space that you're trying to write a solution for. And it has these interfaces that act as contracts for working with those domain objects. Now, if you're not following DDD, just everywhere I say domain object, you think business object, and it's essentially the same thing. So then everything else in the application should depend on these business objects, or this domain model. Right, so with clean architecture, it's also been referred to as onion architecture because of its layers and rings. Before that, it was hexagonal architecture, which is a funny one because it just had to do with how someone drew a picture, and ports and adapters. Right? And so an onion architecture diagram of clean architecture looks something like this, where the middle three rings, the domain entities, the repository interfaces, the service interfaces, that represents your domain model, your core of your application. That's sort of like the crown jewels of the app because it has all your business rules in it. It has all the things that make your system unique and do what it does. Around the outside in that purple layer, that's where all the other things interact with this business layer. And that includes the user interface, any infrastructure concerns for data access, any things that talk to other services, etc. All that stuff is pushed to the outside, and all the dependencies, all the arrows point toward the core, is the idea. Another variant of this is a ports and adapters or hexagonal architecture diagram. It looks like this. And of course, you can tell why it's called hexagonal and not pentagonal or octagonal or something. It's because somebody decided that those middle shapes should be hexagons. But it has these purple dots here. These are the ports. When you think of ports and adapters, those ports are interfaces. And so the implementations of those interfaces are these things around the outside, like an in-memory object store for persistence versus a relational database store for persistence. Those are implementations of those interfaces. And those are the things that would live in another project, in infrastructure, and get injected into your application so it would use one or the other. All right. So the rules for clean architecture are pretty simple. And here's where I would make a Fight Club joke, but too many people haven't seen that movie now. So
oh no, we're at that point now.
I know it's crazy. Yeah. So the application core is where the domain model lives, right? I usually call it core because it's like the core of the onion architecture. Sometimes you'll see it called domain or some combination thereof. I think in eShop on web, it's called application core. There was a little bit of a problem for a brief while when .NET Core came out and there was some confusion there, but I think we're moving past that here in the next year or two, hopefully. And so that has your domain model. All the other things point toward that core project or that inner project. And then it's where the interfaces are defined and the outer projects implement them. That just has to be how it works, because you have to have a reference to an interface in order to use it. And so they have to be defined inside the innermost, most dependent upon projects generally. All right. You want to avoid directly depending on the infrastructure project. The infrastructure project has all the nitty-gritty implementation details of how you're going to do stuff. And so if any other part of your application has a direct dependency on it, because of that transitive dependency, you're now directly depending on the file system or Cosmos DB or your SQL Server or whatever it might be. And you don't want to directly depend on those in your whole application. It's fine to directly depend on them in the infrastructure project. That's what those are for. But you want to keep your UI and especially your business objects independent from those implementation details. Okay. Some of the features of clean architecture before we jump in and show the code. It's framework independent, so it works regardless of which framework you might be using. It doesn't care what kind of database you're using, or even if you're using a database. It's UI independent, so I'm going to show you an ASP.NET Core solution, but you can use it with a Windows service or a worker service or an Azure function. It doesn't really matter. It's pretty agnostic to all those things. It's very testable, especially the core domain model. That's one of its best features, in my opinion. If you want to refactor to it and you already have a system, there's basically a few ways you could start, right? If you're starting greenfield, then it's best to just start from something that's already properly organized, and it'll save you a few hours of trying to figure out how to structure things. And that's what we're going to look at in just a second, is the starter solution template that I have. If you have an app that is just one project, like one ASP.NET MVC or ASP.NET Core application, then that's easier to refactor into these separate projects. The hardest place is where you have a multi-layer architecture already, and it's not following the DI, dependency inversion approach. It's following that N-tier structure that I showed you, where the UI depends on the business logic, which depends on the data layer. That's going to take a lot more time and effort, and you may want to get some assistance from someone if you need it to help you with that refactoring. All right, so now, what goes into the core project at the center of the universe in these applications? This is where you're going to have all the interfaces that relate to your business model. There might be some interfaces that live elsewhere, but most of them are going to live here. You're going to have your domain model, which is going to be made up of entities, value objects, aggregates. These are DDD terms, but they're just different classes that represent parts of your domain model. You might have some domain services that perform some logic. You may have some domain exceptions or business level exceptions. I'm a big fan of custom exceptions for things, so that if you go to try and add a product to an order, but for whatever reason the product is null, instead of you getting a null reference exception, you should get a product not found exception or argument null. Or so, I don't know. It's probably not the best example, but you should get a business level exception that says that this thing was not what I expected, instead of a low level argument null exception or null reference exception. That's the worst of them. That's definitely my least favorite exception, is the null ref, because it never tells you which thing was null. Like,
Right.
you have to know, like, at least tell me the name of the variable or the type of the variable, something.
I can't deal with it. It's like in C++, the worst one is the segmentation error or the segmentation fault. It's like, thanks.
Yeah.
Oh man.
That's useful. Thanks.
Yeah.
And where were you when this happened? I don't know.
Deal with it. It's 2 a.m.
Yeah.
Good luck.
Another set of things that are often in your domain project are domain events, and oftentimes they're event handlers. So if you don't know domain events, it's worth spending some time to check them out. These provide a great way to decouple things inside your domain model, so that when something happens and some other stuff is supposed to happen too, you can separate those out. So you don't have to have one method on an entity that says, like, hey, when I check out, I need to charge their card, decrement the inventory, create a shipping label, send them a notification, blah, blah, blah. Like, all those things don't have to happen right there. You could just trigger an event that says, hey, customer checked out event. And then all these other things could happen as handlers for that event, instead of having to happen all inside one huge method. It's a great way to break up some things in your code. And then specifications, which we'll look at in just a second. Specifications are a way to encapsulate query logic, which is data access logic, really, but it's agnostic of your data source, and put that inside of your domain model. The nice thing about specifications, and we'll look at them in just a second, is that they have a name. So you can see what it is by referring to it. A lot of folks these days, when they're building their data access, even if they're using some type of abstraction layer, a lot of times it's just link code that they're passing around. And so they're like, well, give me customers, C angle arrow, C dot name equals this, and country equals this, and company equals that, and you have this big blob of link that is the data access code. But that ends up spreading all over the application. You'll see link queries in controllers and link queries in services, and they're not in any one place. And a lot of times they're duplicated, and then maybe one of them needs to change. You change it in one place, but not the other. Now you've got behavior that's not consistent. You can't really just save a link query by itself, right, and give it a name easily. And so specifications kind of solve that, and they give you a way to store that query and the link logic that goes with it, and then use that specification with Entity Framework very easily, for instance. All right, so let's look at that in code. That's enough of me talking, and let's briefly talk about how you get started with this template. So I just ran this right before we started, and so the relevant code is right here. It says .NET new -I, which means install, our dallas.cleanarchitecture.template. That template is out on NuGet, and so if you do a NuGet search for our Dallas Clean Architecture, you'll find it. And then you run this one time, and now you have it installed. And so if we go to another folder, like dev scratch, and then scratch, if I can type, there we go. And then we run a command to create a new solution, which I have already over here to copy paste. So we'll create a new instance of Clean Architecture using Microsoft.vs Toolbox as our company.project name. It'll go ahead and create that, and it created it successfully. So then we'll go into a new instance of Visual Studio.
Oh, so I do have a question from chat while we set up in there.
Go for it.
Well Learning asks, what's the purpose of the application layer in DDD?
Purpose of the application layer. It's for application-specific services generally. So if you have things your application needs to do that you want to combine with the view models or the API models or the things the application level of abstraction is working with, then you don't want to put those things into. Sorry, I'm trying to talk while I find this. There we go. You don't want to put those things into the domain model, because now the domain model would know about those user interface concerns. And so for me, when I'm building things and I use an application layer, which I don't always, but when I do, that's what's going in there. It's higher grain services that are designed to support what the user interface needs to do. And then the application service will work directly with the domain model. A lot of the time, you can have your UI work directly with the domain model, though, and there's not a huge issue there, in my experience. All right, so here's what we got when I ran that. So you just watch this thing run. It created all these files, and you get this solution template, not just a project template, but an actual full-fledged solution that has the core, the infrastructure, and web projects, as well as 3 different types of tests that it's going to run. That you can see, and there's already tests in here for you. Okay, so looking at core, we were talking about the different types of things that live there. We were saying like aggregates and entities and things like that. Well, an aggregate is basically an entity that usually has children. And an aggregate you can think of as being a unit of persistence. So when I fetch this thing from the database, I expect it to have this whole thing, not just this one thing. So if you have like a master detail type of relationship, like when you fetch an order, you want it to include all the order items with it, then that would be an example of an aggregate. In this case, there's a sample that comes with it that you can throw away, but it's just there to kind of show you how things work, which is this notion of a project. And the project, let me make this a little bigger for you. That's good. The project has a bunch of tasks, a bunch of to-do items on it. And so it just includes this list of to-do items, and they're in what's called an encapsulated collection, because you don't necessarily want to expose a list from your domain model, because then anybody could do whatever they want with the list, right? They could clear the list or remove items from the list, and you would have no idea about it. So by encapsulating it like this.
Real quick, can you make the font a little bit bigger, or just like enlarge the percentage down there?
One more time?
Yeah, one more time.
All right, let's do 175.
There we go.
Is that better?
Yeah, that's better.
I'd make this bigger too, but that's not.
Yeah, that's a bit trickier.
All right, so this is just a project, and the things I want to call out about it is that it is an entity. An entity is just something that has identity, right? So if it has an ID and you're going to fetch it and pull it out of the database using that ID, then that you would usually model that in your system as an entity. And so there's a base entity type that it inherits from. All that base entity type does for the most part is give it an ID, and in some designs it might also give you some like domain events that it's going to capture for you. And then it's also got this marker interface saying that it's an aggregate root. And we'll see where that's important in just a minute when we start looking at the persistence. But the intent of this project versus this to-do item that it has a list of is that it's like a tree, where the project is the root of the tree, and the nodes under it are these to-do items. There's a collection of them, okay? And so if we look at a to-do item, it's also an entity. So it inherits from base entity, just means it has an ID. It will have, in the database, it will have a foreign key relationship to the project, assuming you're using a relational database. But that's not necessary to show here. If you wanted to, you could add it as a thing, as a property. But generally, since I'm never going to get a to-do item by itself, I'm only ever going to get a to-do item with its parent because it's part of an aggregate. I don't even need that ID, because if I have the to-do item, I must have the parent. That's just the design. But it doesn't have iAggregate root. And so what that means is it's communicating my intent to other developers, to future me when I come back here. If I'm working on this and I'm thinking, hey, I want to just edit this thing and save it, let me take a DB context and call save changes on it with this changed entity. I don't want it to be able to do that directly. I want it to have to go through the repository and force it to use an aggregate root as the unit of persistence. Okay.
Okay.
And there's more to cover than we have time for on aggregates and design and things like that. But that's the short version. Okay, so then these also have. Go ahead. Another question.
I was just before. Yeah, we have a couple of questions actually. If you want to answer some before we dive into the next section. So first question is, can we say that the service layer is the same as the application layer?
Depends on what kind of services they are. So you might have domain services that are inside the domain model, and they only work on domain model types. You could have an application layer that has a bunch of services. So service layer is not specific enough to me to be able to answer that question. And if you're building an API or if you're building a microservice, I mean, when you talk about the service layer of your microservice or of your API, that might be your Swagger like list of endpoints. That could be the UI of your whole app. So I don't want to be pedantic, but service layer means too many different things to different people for me to just give you a simple answer.
Gotcha. Next question is, with DDD and EF Core, is the unit of work not usable?
It's usable. Yeah, definitely. I don't necessarily have it implemented in this solution template, but you totally can add it and it will work just fine. So what you would do with a unit of work is you would have your unit of work would be responsible for actually committing any changes that you're making, and you would do the unit of work would be tied in with your data access abstraction, which will usually be repositories. And instead of saving changes directly through the repository, you might do a bunch of different sets of work, possibly even with multiple different repositories, and then use the unit of work to commit them all at once. And usually under the covers, that's going to be using transactions to do the work. So it's not hard to add that on top of this structure, but if you don't need it, it's not in here because you don't always need it, is the short version.
Gotcha. Other question. This is related to using like the base entity as an ID returner, essentially. So sometimes we have an ID as a string for GUIDs and other times as a number. How can we best handle this?
Sure. So this is the base entity that I'm using right now. This is what you get out of the box. And it is just using an int by default. But I've got this comment here that's telling you this could just be a base entity of T if you need to support multiple key types. So if everything in your system uses integers, then just use this one. If they all use GUIDs, then just come in here and change this to say GUID, right? But otherwise, you can say, hey, I want this to be generic. I want to be able to decide what key type I want to use for each one of my entities. And then you would do this. And now anything that inherits from this we'll have to pick. So if I go look at project here, it's going to give me, hey, base entity is not really a thing anymore. It's got to be a base entity of int if you want that one to be an integer. And if I want the to-do items to be different, that's fine. These could be base entity of GUID. And as soon as I import the namespace, that will be fine. Now, this will possibly break other things that are expecting entities to just have, a simple type and not to be a generic. But they're easily corrected by just going through and flowing the same change to those places.
Cool. And this is probably something more for the end, but before I forget this comment, do you have any additional templates that are like the hexagonal architecture that we're taking a look at now?
I have a lot of stuff on GitHub and on NuGet. So some of those libraries are being used in here. I don't have any other templates except for a clean architecture template for worker service that you can find, and it's probably a little bit less up to date than this one is, but it still has the same structure and everything. So if you want to create a worker service, you can use that as a starting point, right? Which does work great as like background processes or scheduled jobs. And so they would benefit from this architecture too, if they're not doing something where this is overkill, which a lot of times they're simple, so they wouldn't need all this.
Cool. So there's a couple more questions in chat, but I'll let you talk some more and then we can stop and answer more questions.
And are we okay to go a little bit longer since we started a little bit? Okay.
Yeah,
okay. I'm good to go longer if you are. Cool.
Cool. I am down to go over.
All right. So then let's keep focusing in on the core and what goes in there. So looking back at the slide for just a second, right? We talked about entities, aggregates. I'll cover value objects in just a second, and some interfaces that might be there. Okay, so I've got an interfaces folder, and it has abstractions for things like how to send an email without saying how we're doing it, right? It just describes what, it doesn't describe how. So I could implement this with SMTP, or I can implement this with SendGrid or some other service, and implement those somewhere else in the infrastructure project that we haven't looked at yet. And then there's another I2Do item search service. This is for a domain service, which is defined right down here. And it's just got, a couple of ways that you can go find, different sets of items. The main reason why this is even in here is to demonstrate this result type that is another abstraction that you might find useful. Okay, so coming back to domain events, inside of Project Aggregate, there is this new item added event. And I mentioned domain events briefly already. They're a way to decouple, things happening from where they first get triggered. And so in this case, a new item event basically just says, hey, this item on this project was added, right? And so something raises this event. And so if we look at the project, it's got a method in here that says add item, right? And so because we're not just exposing our list of items directly off of our properties, we have to give some way for folks to actually work with our collection. And so we do that through explicit methods. But in those explicit methods, we can add additional behavior. Like in this case, when you add a new item, I'm going to add a new item added event. And then when I save the project, that event is going to get dispatched and a handler will fire in response to that. So if we look at this new item event and we say, where is this referenced? And I know this is a little bit small, but there's a place where it's created, and then there's this place where it's created there. Where's the handler? I would have expected. Oh, maybe I don't have a new item handler. All right. Well, there's a to-do item completed event, which is basically the same thing. Looks like this, just has the item. And then it actually has a handler right here. And in the handler, it goes and sends the email to someone, right? It says, hey, someone was watching this and wanted to know if this thing was completed. So here's your email to tell you, hey, it was done. And so in this case, it's hard coded who it sends it to, but in a real application, right, you'd have some list of subscribers or something. But the idea is that sending the email didn't have to happen inside the project class, inside that method. So when the thing was completed, it was able to trigger this separately. The other thing this lets you do is there's a really common question when folks are building these domain models with entities and aggregates and things like that. And here's the mark complete method that added that event. Inside that mark complete method, if you had a requirement that said, hey, when someone completes this thing, you need to send an email to so-and-so. The obvious way that you would do this is you would put some code, right here. You say mark it done, and then right here, send the email. And how would you do that? Well, you could just use some static method that sends emails. You could pass in a thing that knows how to send emails, maybe, but now your thing is not as nice to use. You might think, hey, I'll just use dependency injection because that's the solution whenever I need a dependency. But you can't really do dependency injection effectively on entities because they need to be created by your ORM, right? Entity Framework is going to create this thing, and Entity Framework doesn't know how to do dependency injection, so it'll just fail if you try and do that. And so what domain events allow you to do is have a way to fire off these things that need dependencies outside of the entity itself. And so if you know you're going to have to send an email after you mark it complete, you just add the event, and then the work that actually sends the email is in this other handler. And you may have to do a bunch of other things too. Like maybe you need to log it. Maybe you need to do other activities. Those could each be different handlers that are each very, very, very focused and simple.
Oh, quick question while we're on the handle topic. What is guard against null, the line that's under the handle definition? Yeah.
Yeah. So this just ensures that this domain event is not null. And so it's an example of a guard clause. And I actually have some slides on that. So let me just jump to the slides, and it's a little bit ahead, but that's fine. Where is it? Right there, guard clauses. And we'll jump back in a second to cover those other things. But a guard clause is just a really simple pattern to jump out of a method quickly if you find that it's going to be an error anyway. And they clean up your code so that they don't have a lot of noise inside the method around doing error checking. And basically you just invert these checks. So if you had a process order method like this one, and it said, well, if the order is not null, if the customer is not null, then do the thing right here. Otherwise, throw an exception for customer. Otherwise, throw an exception for order. Like, this is a lot of noise.
Yeah.
For you can't even see what the real work is right now. If I had some, right, you'd see it, but it's obscured by all this if stuff. Guard clause would say, check if it's null, and if it is, blow up, and check if that's null, and if it is, blow up. And so those are examples of the pattern guard clause. Now, if you go out to NuGet, you'll find that there are some different packages out there. And the one I'm using is my own, our Dallas.guard clauses, that define a bunch of common things you might check for, and then let you have a very consistent way of doing these checks. And it's extensible, so you can add your own as well. So if you have an application where certain things always have to be true, like every method or every entity always has to have this property on it, and if it's not set properly, then something went wrong. All right, you could put a guard against my special case in there, and with one line, you'd have a very consistent way to check for that sort of thing. If you look inside the code for guard against null, it just does this, right? But it does it in a consistent way, so it's the same every time. Yeah. And later on, if you want to change how you do it, you just change it into one place and not have to go change every one of these.
So much cleaner, yeah. I think we've all been there with the nested if statements to check for null for lots of different objects. Yeah.
If really statements useful. They're often sort of the enemy, right? And when you look at a method and it's got like 5 levels deep of indents from if statements, that's the worst. Like you're gonna need to refactor that and pull some of that out to make it less convoluted.
Right.
All right. So those are the events and the handlers and kind of how they work. Then the last bit that's in here that I want to make sure I talk about is a specification. So if I want to get a project and I want to make sure I get the project with its items. Right. Well, if I'm using a DB context directly, I can easily do that in EF Core by just saying, go give me, DB context.projects, where ID equals this, or first or default of ID of this. Oh, by the way, include project.items. And if I needed more stuff, I might say, then include this other thing. Right. So that's all stuff that Entity Framework understands, but you got to remember to do it every time. And I don't know about you, but sometimes I forget. And so I'll create this query and I'll try and fetch the thing. And I want to go see what the count of this sub property is. And it's blank and it's 0 and it's null or it's not set. And I'm like, why isn't this working? I know I just added this thing. And it's because I forgot the include. And so EF is not populating that property for me. And that's fine. That's what it's supposed to do. But I don't want to have to always remember every time that I need to do exactly this or that include. And if I'm using a really, dumbed down repository pattern that just knows how to like get by ID and it just gives you the thing, but it doesn't do any includes, that's often where you get bitten by that. It's like, you don't necessarily remember that, oh, wait, that's right. It doesn't actually give me all of the related collection properties, for example, or navigation properties even. And so this specification basically lets me remember a query like that and then reuse it anywhere in the system. And so I have a repository that I'm using, and it understands how to take in a specification, and then it translates that into a query for Entity Framework and gives me back the appropriate result. And so I'll show you how that works in just a minute. But you can make as many of these as you want. You can name them. Usually I group them with the aggregate. So, for a given aggregate, like a big application might have a bunch of different aggregates, right? You might have a customer aggregate and an order aggregate and a something else aggregate. And so rather than having top level folders for things like events and handlers and exceptions, it often makes sense to group those by aggregate, right? These events only make sense for the project aggregate. And this handler is only for the project aggregate. These specifications are only for the project aggregate. So I don't want to put them in the root level and have, thousands of them. It's better to organize them like this, I think. And they can be more complicated, right? So here's an incomplete item search string that checks for stuff. If you've got rules where you always want to make sure that your soft deletes are not included, right? So you always want to say like is deleted equals false, or is active equals true, or something like that. Those are things you would certainly remember to put into your specifications, but someone might forget if they were just on the fly doing some link query in a controller.
Mm-hmm. Yep.
Okay, so that's how these work. This to-do item search thing, I think actually uses, this has an example of what a repository looks like. So here's a specification and a repository call to get it. So this is a search service, but it's a very abstract search service, right? It does not know about the database, does not know about how it's going to use, doesn't even know about entity framework, right? It's in the core project because it has no dependencies on any implementation detail.
That's great because it's ignorance is bliss sometimes.
Yeah. And the nice thing about that is that you could totally unit test this, right? It does not need a database, does not need any real stuff at all. And so I've got unit tests for it down here that we could look at because there is some complexity in here, right? There's try catches, there's if statements. And so you might want to verify that all this stuff works with a unit test. And it's trivial to do that because it's in the core project. It doesn't have any dependencies on those things that make unit testing difficult. You don't have to really, worry about it. So the way this works here is you just create that instance of a specification. You pass in anything it needs. So this is saying I want to get the whole project with its items by ID. So I pass in the ID, and then I await, get by spec async, pass it in that specification, and now I get the project. And I know at that point it's going to have all its items with it, without me having to deal with the DB context directly, without me having to write any link stuff here, because link is hard to reuse without copy paste.
Yeah. Again, it's so much cleaner, for lack of a better word, having like at first glance, it's easier to understand the function of this particular method in this case without having to go deep into the DB context. Yeah, so that's great.
All right, so that's most of the stuff you would care about in this. All right, so then in infrastructure, like the other thing that I want to make sure people take away from this is when you look at a lot of applications, even ones that use like the repository pattern, you might find that they have lots and lots and lots of repositories. Right, so they've got like 10 different entities or 50 different entities, and every single one of them has got a repository class somewhere that knows how to talk to it. This is my whole data layer, right? It has an app DB context because it's using EF core, so of course it does. And in there it has a DB set for each thing. Now, obviously, that'll get longer as this becomes a real project with more things, but we don't add any more classes, right? It's just more properties on here. All the configuration is in here. So you will add another file for each new entity you add where you configure it. That's just because I'm not using the data annotations attributes. I want to keep the core very clean, again, for lack of a better word. And so I prefer to put all the configuration of the entities inside the infrastructure project because the infrastructure project is what is supposed to know about the data store, not the core. And then this EF repository is this long. Right, I've got some commented out code here that I'll show you, but it's using a repository, a generic repository that ships with this Ardalis specification NuGet package. And so you just add this thing and then you assign it whatever interfaces you want it to use. But its base behavior includes all this stuff. And so the one that we were just using, which is the reason why this is still here, is the get by spec async. Do I still have that here? Maybe I don't have it here. Well, there's one that takes in a specification that isn't in this comments, but I can show it to you in the other project. The cool thing here is that in this thing, I don't need a bunch of repositories. In fact, I only need one generic one, and it's barely any code at all, and it does all the work. So I haven't actually run this app yet. Maybe we should do that. So let's run this and see what it looks like. Cool. Again, it's a solution template, so it's kind of like a hello world thing when you run it. But just to kind of prove it works, here's what you get. It's got some stuff in here that says like how to use this template with various things. You can see what all the APIs are. So it's got Swagger support here. It shows you like it has some seed data, so you can look at a project. There's a project in there called Test Project. Excuse me. And its things are not done yet. And so if you want to test this thing and actually mark things as complete, you can actually go in here and find, like, here's a list of incomplete items. Let's try it out with number 1 and execute. And so there's the search string is required. Okay, fine. So search string is, shoot, what would be, I got to remember what the things were that I can search for. How about working? That'll work. So go back to the home, go back to Swagger, and look for working, capitalized, and try it out with 1. And I don't remember if it's case sensitive or not. There we go. And look at that. It actually brings that thing back, right? It is done as false.
Yeah.
And then we can mark that as complete. So here's an API that uses a patch to mark it as complete. So that was ID number, don't know. Oh, it's because it's using in memory. That's interesting. It's not usually a thing. Why is it using 0? Weird. I don't know what this will do, honestly. Usually it's using SQLDB. No such project. Yeah, okay. So why is it? That should be 1 and 1, I would think. Maybe, I'm not sure why those IDs didn't get populated. 1 and 1. Let's try it. It's thinking about it. Oh yeah, okay. This is expected. All right. So it worked, and it tried to send the email. So because we completed a to-do item, it's now trying to send an email, and I don't have an email sender set up. So right now it's trying to send on my port 25, and you can create a test email sender. You can use SMTP for dev or something similar, and it will listen and it will pick that up. I do have to figure out why this thing returned back zeros for those. That's concerning me. But everything else here is working just the way I would expect. And if we had more time, I'd show you how to use SMTP for dev.
Gotcha.
All right, so that's all that. That's the front end. Let's lastly look at Asp Net Core, since that's the type of tech we're using.
Right. Can I ask some more questions from chat
before
we go into that? Sweet. So first question is, how can CQRS, it's a command query something, and the mediator design patterns be implemented in the structure?
Oops, that's the wrong screen. CQRS is command query responsibility segregation. That's what I was looking for, was that screen right there. All right, it's where you are. And the mediator design pattern, you don't have to use CQRS with mediator, but they can certainly work together well. The idea with CQRS, briefly, is that you want to separate things that mutate the state of your application, which are commands, from things where you're just asking for information, which would be queries. And so in this example, if you looked at my API, I didn't have a lot of things that were both manipulating the state of something and returning you back data. So when I made that patch call to update an item and say it was complete, which isn't necessarily, not every REST or whatever implementation would use patch for that, but let's just leave that aside. When I made that call, it didn't return back a query and show me all the items that had been updated, right? It just did its thing and returned okay or not. In this case, it returned a 500 because it blew up trying to send the email. But if I had an email sender, it would have just returned like a 202 no content or something like that, or 204. So then if you want to find out the details, you would go and make a query. Now, why is that important? Well, it can be useful for scalability as well as simplifying your design. You don't have to do as much validation when you're just doing a query as you do when you're actually mutating state. You need to make sure everything is valid before you would mutate the state, because you don't want to change into an invalid state. But for a query, you just need to know what they're looking for, and then you give it to them. And so it's a lot simpler. Also, the way you architect the backend could be different, because your queries could all be hitting a cache or a separate data store that isn't the thing that is your transactional data store that all your commands interact with. And so that's another reason why you would want to split it. And then on top of that, on top of like the actual infrastructure of how you store that data, there's different patterns you could use on top of it that are helpful for scalability as well. So commands are really amenable to being wrapped up in messages and then distributed over some message queue or message bus, and then other processes can process those commands. So you don't even have to have your app do the work. You just need to like encapsulate that command and throw it on the wire. It goes on a queue, and something else eventually does the work. It's harder to do that if your application is designed to also do a query right after the command fires, right? You want to be able to just say, I got your command and I dispatched it, I'm done. Now then your queries, on the other hand, they benefit from caching. They benefit from caching as a separate service, like a Redis cache or something like that. You could also do caching in your application. You can't usually cache commands, and you can't usually dispatch as a message a query, right? Because your query, the user is sitting there waiting for that response. So you don't want to dispatch it off and have it sitting on a queue for a while. And so those two different patterns, dispatching commands and caching queries, work really well as long as you keep those things separated. As soon as you combine them, then it gets a lot nastier and you can't really use either one of those patterns. So hopefully that answered the question probably with more than they were looking for.
No, that was great. The more the merrier. The next question is, what's better, EF core lazy loading or EF core include?
I am not a fan of lazy loading in web applications. Lazy loading is great if you're running a Windows app and there's one user and they're moving around inside and opening up records and looking at their details and things like that. Like that's great. Run that WinForms, WPF, single user web app that's running on someone's computer using lazy loading, and that's what it's designed for. When you're building a web application, what you are having each request do is try and return back to the user's browser or to the client that's calling your API in zero time, right? You want to measure it in milliseconds at the most. And so if you use lazy loading, what that means is that you're going to make more queries to the database. And every separate query you make to the database is going to be another round trip, which is going to take some non-zero amount of milliseconds to perform. And so the more of those you have, that quickly adds up so that now your responsiveness of your application suffers. And so I will always prefer to make fewer calls to the database, which means using .include in a web context. You can very quickly, especially if you do lazy loading in a loop, very quickly have a tremendous number of database calls happen and not even know it with lazy loading. And so it may run perfectly fast on your local dev machine with 3 records in the database, but then when you deploy it to production, that's when you notice that it's actually making hundreds of database calls on your company's homepage or whatever. And why is the site so slow?
Great. And one more question, and then we can go back to the content. So technically, you can have n number of classes for each spec. That seems hard to major with master/detail list.
N number of classes with each spec. So let's go look at a spec. I think what they're saying is, if I try and name this thing project ID with items, for instance, and it has, 10 different sub collections, if I have to create a different spec with every different combination of those things, that's going to get crazy. I think maybe that's asking.
Yeah, that was kind of my interpretation.
Okay.
Yeah. So how do you handle that?
If we looked at, let's say, our aggregate project here, and if it had a bunch of these types of collections that would not be would not be loaded without an include unless you were using lazy loading. What I would do is I would just have, since this is an aggregate, and since an aggregate is supposed to be persisted as a unit, in that case, I would rename this spec to be something like, project, aggregate, and that's it. Like if I say it's an aggregate, I know it's the whole thing. Like to me, that's what that means to me. If your team doesn't think of that or doesn't know it, you could say project ID with, all dependencies or all collections or all children or whatever, right? And if you just say with all children, then it could include the items and the owners and the companies and the whatevers, all of those things in here. And when you add more, you don't have to change the name of this thing. You just change what all it includes, and all of your code still works.
Yep. Cool.
Anything else?
One more question, and then we can go in. So, you're getting lots of questions. In which situations can we not use a generic repository class?
In what situations? Is that what they asked?
Yeah.
Very rarely with this approach, right? If you're not using a specification, then there's all kinds of reasons why you won't use a generic repository. So without a specification, the problems you run into is that your generic repository, let me show you one real quick. Let's see, here's this. And if I go to this old one that I have here, So here's a generic repository, and it looks something like this, right? It's got get by ID and list, add, delete, edit. That's it. And then this one's got this list with an expression, which is sometimes handy. If it didn't have that, then it'd be even worse, right? So a lot of them are just get by ID, list, add, delete, edit. And what often happens is your generic repository falls down as soon as you need any kind of custom query. You're like, well, I need the order with its items. So I can't just use get by ID because it doesn't know that it's an order. So it doesn't know to include the items. So I have to create a separate thing. So then you end up creating, and I don't know if I have an example of this here. Like here's the generic one. Yeah, I don't show the specific one. So you can create a generic one easily enough. And here's what get by ID would look like. It would say, here's your DB context, go get something of T, which says order, find the ID, and boom, here it is. Right, but what do you get with that? You just get the order. You don't get any of its children because it has no includes in it. And even if you do the list that this one provides and gives you this where predicate where you can just pass in a lambda, it also doesn't do any includes because that's just beyond the scope of this simple version. So what you do in that case is you end up creating subclasses of this where you have an order repository that inherits from repository of T, and it says where T : order to restrict it. And then it adds more methods. It says, get by ID with children or list active orders or get orders by customer or whatever else, right? And so you add all these extra things to it. And that just multiplies how many data access classes you have. So you've got all these different data access repositories with different methods for doing these queries. Specification gets rid of all that because as soon as you have one method on here that takes a specification, and I can go out to that project real quick, then you don't need to do any of that, right? The specification, where's my docs? Read the docs. And getting started. Can I show an example? Oh, wait, I'll show you the actual sample here. So here is a sample, and it has in core, it has some specifications, and you do like customer by name with whatever. So this is similar to what you're just seeing in the clean architecture. Like I can define that query, and instead of having to have a different repository with all these extra methods on it, and they just keep getting longer and longer, I just create a different specification for each different custom query I might have, whether that's how I'm filtering, whether that's the shape of the data I'm getting, because you can actually do selects on here too. So if I don't need the entire row, I only need like these 4 columns of it, I can do projection and selection in here as well. Using this project, using this NuGet package, and whether I want caching, which this is showing, so you can just enable caching here pretty simply, and if I need to do includes, right? All those things are in the specification, and that's why the repository is trivial.
Cool. Yeah, that's awesome. Sweet. So
let me show you the repository since we're in here anyway.
Okay.
And so I think I gotta find it. So T repository. That's not it. Oh, I can't spell. It's funny that one actually came up. Here's the thing. All right. Well, there's the interface, but where's the actual implementation? That's the interface. No, that's the wrong one. All right, I gotta find it. Sorry.
No worries. We're a little short on time, so I know you still wanted to talk about the back end, if you want to give like the Spark Notes version of that as well too.
The front end, actually.
Oh, the front end, excuse me. Yeah. Yep, the front end.
Here's the repository. Sorry, that took me a second. It's in the specification.ef core, right? There's a different version in the EF6 one. So if you're still using EF6, you can use this. And the most important one in here is the ones that use the specification. So this one right here says, get by spec async for a given specification. Will apply the specification to the query and then return the result. So when you look at the apply specification, there's this specification evaluator, and that's where all the magic happens, where it applies the includes and the wheres and everything else. All right, so that's enough for you to know about how that works. Let's spend the last minute or two that we have looking at the Asp Net Core. This solution template, if you ever do file new Asp Net Core project, right, which we've all done, you're going to have a choice, and it's going to say, well, what kind of project would you like? Do you want to have an API or an MVC or a Razor Pages or this or that? And so I didn't want to have to do that, so I gave you all of them. And so if you only need an API, you just delete the things you don't need. If you only want Razor Pages, just delete all the APIs. Okay, so here's an API controller, and it's got this projects controller in here, and it just has how to get all the projects and get by ID and things like that. It's got Razor Pages that kind of do the same thing and show you the projects. It's got views that kind of show you the same thing. You probably don't want to have pages and views in the same project, so pick whichever one you like better and delete the other one. Mm-hmm. And then it also has endpoints, which is sort of a better way to organize your APIs. So instead of having this controller that's this big, long, convoluted thing you have to sort through, and it gets longer and longer and longer every time you add an endpoint, and none of these things have anything to do with one another, right? This one never calls this one. If I'm working on this one, I don't care about this one. So that's a reason why controllers aren't really a great organizing tool for APIs. So instead, you can use endpoints, which are shown here, and it's basically one class per endpoint. So here's my endpoint, and it only has the dependencies this endpoint needs. It doesn't have all the dependencies that anything else in my controller needs. And the types it needs are right with it. So it's kind of like Razor Pages for APIs. And this is coming from another NuGet package I have, which is this Ardalis API endpoints package. And it just makes it so that you can have your controllers have exactly one method per controller. So we're probably close to time at this point.
Yes, we are.
That's what I wanted to show.
That is awesome. This is really, really good content. I love seeing the architecture stuff that can just help keep your code clean and easily extendable in the future. So I think the big question is, where can people go to get started with both this template and any of the other stuff that you demoed today?
Sure. So if you go to NuGet.org and just search for Ardalis, Ardalis, that's me. And so you will find all the different packages that I have out there. Here's the guard clauses one someone asked about. The clean architecture template is somewhere down here. It hasn't gotten nearly as many downloads, so it's kind of down lower. Just updated it an hour ago, you can see. So it's got the latest Asp Net Core dependencies. Specification is in here. The what's the other one we use? API endpoints is in here. And the result abstraction that we didn't talk about much, but it's in the project as well, is in here. So NuGet is a good place to just search for Ardalis, along with my GitHub repo. And if you want to read stuff on my blog, go to ardalis.com and /blog, and you'll find various articles on things like, should I use lazy loading and things like that.
Awesome. This is really awesome content. You got a lot of comments and questions in chat that really showcase how useful this is. And for questions that we didn't answer, I'm sure they can follow up with you on Twitter and stuff, right, too?
Yep. Or in the various packages, they all have issues, and I think most of them have discussion as well, or ask on Stack Overflow and just tag the thing. But like, there's a discussions tab here that maybe this one's not set up, but people ask questions on issues too, and that's fine. So
great. Yeah, and we'll probably just have to have you back, because I'm sure there's a lot more content that you didn't get to share that would be great for everybody.
Yeah, a lot of these packages you could talk about for an hour all by themselves. So
yeah, I believe it. It looks like you got a lot of them too, so that's great. All right, so thank you so much again, Steve, and thank you so much to the viewers. Go check out all of the amazing NuGet packages and templates that Steve has created under Ardalis. Ardalis.com, you said, was where your blog is at as well.
That's right. Yep.
Great.
And I'm on Twitter and GitHub. I'm Ardalis everywhere. So
yeah, and I hope everyone writes some clean architecture. And until next time, happy coding, y'all.
Bye.